Welcome to the Jack Westin MCAT podcast with your host, Phil Hawkins.
And Azaii Muñiz. Hello, and welcome to the Jack Westin MCAT podcast. We are your hosts. My name is Azaii Muñiz, second-year medical student here in Boston, with my fantastic co-host,
Phil Hawkins. I'm the MCAT director at Jack Westin. I also went to med school at the University of Nebraska Med Center, where I was an MD PhD student doing my PhD in learning and memory and stuff, which is surprisingly relevant to like MCAT prep kind of overall. Today, we're going to talk about my favorite section of the test, which is chemistry and physics section, or the chem-phys section, as I generally just abbreviate it because I'm lazy. And everyone knows like what I mean when I say chem-phys or psych-soc or bio section. But those of you who know me know that physics is my favorite topic in the world. I was a physicist in another life. I really like equations and that sort of thing. And I am in the minority. I know most students probably don't agree with me about what is the greatest topic to discuss, but I really love talking about physics. But the chem-phys section has some particular challenges that I think a lot of students you have to study the chem-phys section differently than the other sections, and there's some individual unique challenges that arise in that section. So I'm pretty excited to talk about some advice for dealing with that section specifically. What's your feelings on the chem-phys section?
So I'm someone who I loved a lot of the math and nitty gritty in high school, and we're going to go through the whole progression. In undergrad, not so much, had a lot of rough experiences with chemistry and physics. So I was really apprehensive about taking a look at that chem-phys section when I first started studying, because I didn't know what I was getting myself into. And so I think hopefully for the folks who are listening to our podcast and who are exploring the chem-phys section for the first time, we can help orient you so that you're not as freaked out as I was when I first started preparing for this section, just because there are a lot of moving parts, right? It differs from the biochem and the psych-soc section in important ways. And so it's important to just make sure that you go in with a peaceful, kind of a peaceful mentality, so you're not freaking out from the onset.
Yeah. So let's just talk about big picture, what are some of the differences between the chem-phys and some other sections. I think that the chem-phys section, first off, it's really important to know it is not just chemistry and physics. Despite the name of the section, it is 55% chemistry and physics, so just a hair over half. And then the other 45% is bio and biochem and orgo. And so I think a lot of students just assume it's just going to be tons of chemistry and physics, but everything on the MCAT has this kind of biological medical slant. And so, you sit down and take an exam and you're in the chem-phys section, and it might be you might see 7 passages that are just predominantly about biology that just have some chemistry and physics questions kind of peppered in there. And so I think that's an important thing. The MCAT actually used to be very different way back in the day. I feel like I talk about the old MCAT way more than I should, but it's important to kind of understand what it is that the MCAT writers care about. And the old exam, there was a passage. This is a physics passage with physics questions. And then here's a chemistry passage with chemistry questions. And the new MCAT isn't like that. And I think that makes it a little bit more difficult because students tend to learn about topics as separate things and kind of separated in your brain because of how you are taught. So you talk about redox reactions in biochem and in general chemistry. You talk about oxidation numbers. You talk about circuits and electrons flowing, which is something is gaining and something is losing electrons in that setup. And you don't tend to think of those all as the same thing. But what's going on when you turn an aldehyde into a ketone is very similar to what's going on inside of a battery or what's going on in your electron transport chain. And people don't because people learn about these all separately, they have a hard time kind of blending the topics. So when they get a question about a battery, they don't think about the electron transport chain. And that's one of the big challenges of the chem-phys section, is starting to realize how a lot of the chemistry and physics, you can't just keep that in a box separate from everywhere else, but figure out how that integrates with other topics and how magnetic fields would affect the activity of a neuron, right? And that's probably something, first off, your physics professor probably never talked about neurons and your neuro professor never talked about magnets. And so like you have to take these things and start to integrate and put them together. And I know that that's tricky for a lot of students because they tend to just compartmentalize information because it's compartmentalized when you're taught it. And that's a little bit of a challenge overall. There's like, you sound like you want to say something, Azaii.
Yeah. So when you were talking about this and you were talking about the neurons, one question in particular came to mind, and it was relating neurons to electric fields and asking about, the direction of like the electric force and whatnot. And I remember when I first looked at that question, I laughed because I was like, how am I supposed to know this? Right. And it's something that, like you mentioned, we're taught all of these things very separately. And a lot of what a lot of you who are listening to us will be doing in the future is combining information from a lot of different specialties in medicine, right? To make sure that you understand how they interconnect, how they can affect each other, how they are similar, right? I think we've talked about the cardiovascular system being pretty similar to a lot of physics, flow, and dynamics in the past. But something that can be really helpful and that I found really helpful with that, and we'll get into more nitty gritty later on, is just as I'm practicing, trying to actively make those connections, right? So yes, I'm learning some of this material in an isolated fashion, but that doesn't mean I have to keep it that way as I'm learning it, right? So as I'm learning, as we're making study guides and study sheets, something that I find really helpful is looking for those connections. And then as I find them, or as they kind of just click for a moment, jot them down. And that way you're more likely to remember them in the future. You can explore them in the future. And as you get questions, you have that baseline already there.
Yeah. And not only like, if you're doing that, you're learning to, like, you might make these connections. Like a mass spectrometer uses magnetic fields and it can be used to look at proteins. Like that's something that you don't just want to memorize that, but you want to be able to think about things in those ways. And so even if like you don't get any questions about the sort of relationships that you were thinking about as you were studying, like thinking about those as you're studying makes it easier for you to think in that way where you're like trying to make connections between different things. I actually think that this is one of the biggest failings of a lot of the test prep companies when it comes to chemistry and physics is they also tend to teach things in this way where it is compartmentalized. And not only that, but they tend to focus a ton on the math. I know I've said this before, but it's like a really important thing to understand that the MCAT writers, the AAMC, is not looking for mathematicians. They're looking for people who understand relationships. So they're not going to give you like some big calculation that takes you like 3 or 4 minutes to actually do the calculation. They want to see, do you understand how these things are related to each other? And so a lot of times the actual math that you have to do is the easiest part of the question. The hard part is figuring out like, how exactly do I tackle this? What things do I need to relate to each other? I think one of the best examples of this, so the very first passage of the AAMC section bank. So this is a passage written from the AAMC. It has 3 calculation questions. And those 3 calculation questions, what you have to do, in the first question, you have to take one number divided by another number. And it's like 4.5 divided by 0.5. And that's something that there are like elementary students, upper level elementary students, but still elementary students could probably do that. Or a question like, what's this number divided by 2? Or the other question is multiply these 2 numbers together. And it's like 2.2 times 2. And like that's like those are all 3 of the calculation questions, right? This number divided by that one, this number divided by 2, and multiply these 2 numbers together. Like, and that sounds really easy. And the math is easy. Now, not all math questions, but like the vast majority of the questions that the MCAT gives you, they are designed to test, like, can you understand how these things are related and how to put these things together? They're not about math. I think that a lot of test prep companies, I'm not going to name any names here, but a lot of test prep companies focus way more on the math. That these questions, that the practice questions that they have are very clearly written by people who have like a chemistry PhD and are like chemistry professors, and they know chemistry. But in undergrad, the challenges on like your chemistry exams very often is the math. And on the MCAT, that tends not to be the biggest challenge. So there's a lot of times when I'm like looking at practice questions from other companies, because it's like a student has a question that I'm working with, I will I will run into a question. I'm like, the MCAT would never ask you to do that. They're never going to make you do like a plug and chug with a Nernst equation where you have to take like the natural log of 1.7, right? Or like doing the Bernoulli equation. That's like a big plug and chug, and none of the things cancel out and none of the things like simplify. And so you have to plug in like, however many, like a dozen different values and like do this big calculation. And that's how a lot of students are taught. I think that it's really important for students to understand this, because if you find yourself struggling with like the homework for your assignments or struggling with your like trying to understand something, if the struggle is coming from the math side, I wouldn't worry about it as much as if the struggle was coming from, I don't understand, like, why does this light create an ion, right? This like photon of light. Well, it knocks an electron off of the element, right? And so like it's the big picture things that I think are more of the challenge when it comes to test day rather than the math. The MCAT writers are looking for you to figure, like they want to see, do you understand how these things are related? And they know you only have about a minute per question. And so they can't throw a bunch of crazy math in there, because if they do that, then they don't have the time to ask you about the stuff that they really care about. And so that's a really important thing. I know a lot of students are out there prepping with all sorts of different materials. And I think that is something that you should keep in mind. Now, I'm not going to say that any MCAT exam won't have like a couple, like maybe one or two, like more complex equation, like plug and chug solve things, but not a ton. Each exam is going to have about 15 physics questions, for example. I would expect maybe one or two of them to be a little bit more complex in the math. So that's like one or two questions out of 230 that's on your exam. And I think students are spending way more time working on their math skills than they are trying to develop those relationships and understanding how these things fit together than they should, based on how the MCAT is testing these things.
Yeah, as you were talking, I had a couple of different ideas, and I actually want to walk through an example because story time, right?
Mm-hmm.
But I want to walk through an example of kind of what Phil's talking about in terms of, with the Bernoulli equation. You could have a whole lot of values, you could have a whole lot of, plug and chug going on, a lot of math, but the MCAT's often going to simplify it for you, right? But it's going to expect you to know how to simplify it, right? So it'll give you the information in order to do that. So let's say that you have, and something I see all the time, right, is you have like a barrel, you poke a hole in the barrel, right? And water starts flooding out from the hole in the barrel, right? So they might only give you two values, and those two values will be enough to calculate the rest of, or to calculate the third variable that you need. Why? Because you have to recognize that what you're interested in is the height differential, right? What you're interested in is the relative difference in speed, right? Because at the top of the barrel, that water is basically not moving compared to the water that's coming. I wish I had like a barrel in front of me, but the water that's coming out. And so a lot of students, what they'll do is they say, well, I don't have enough information to calculate this. So how am I supposed to do it? Pause, right? And recognize, okay, I don't actually need some of the information that I think I do. They've given me everything I need, right? Very rarely are you going to even see the option cannot calculate, right, as an answer choice. So that's a hint right off the bat that you can usually simplify things a lot more than you think you can. And so pausing, breaking that down, if you're unsure about how to approach the question, right? So something that we do in the course with the homework, at least in the car section, you're going to review it, but try it again before you sit down and try and understand every single component of each answer choice. See if you can follow a strategy, right, to make sure that you can get to the right answer. Now, the science sections are a little bit different. Actually, they're quite different, but you can still follow that. So if you know that, hey, I'm trying to figure out where my issue with this question is, right? And I know I have the time for it. And this is when you're reviewing, not when you're taking a practice test, not when you're doing a practice passage. You can go and say, let me try and look at it from a different angle before I jump to the answer or before I jump to the explanations, right? Is there a way to simplify this equation at all? Is there a way to, maybe this wasn't the equation that I even needed to use, right? Is there another way to go about it that's a little bit easier? So this is something you'll do later on. You're not jumping, you're not doing this right off the bat, but it's a way to make sure that, like Phil was saying, you're not spending more time on the math than you need to make sure that you're understanding the relationships. Because something else that I've noticed, and something that I sometimes still do even as a medical student, is I'll read an explanation for something. I'm like, oh yeah, that makes sense. And then I'll keep going. And next thing I know, I'm tripping up on the same thing. Why? Yeah. Because I can read it and understand it, right? That's why I think I understand the topic in the first place. But there's something about struggling with a question type that you keep missing, a topic that you keep missing, and trying to look at it from a different angle before immediately jumping to the answer or to the explanation, that can be really helpful, particularly in the chem-phys section, where, like Phil mentioned, you have chemistry, you have physics, you have orgo, you have a little bit of bio and biochem, right? So unless you truly understand the question, and I'm making all of these hand gestures, but I'm trying to keep them under the line of the camera. But unless you really understand, right, where each of those hangups are coming from and stemming from, it can be really hard to tackle it and feel like you're making true progress if all you're doing is, reviewing topics in isolation, not really giving yourself the chance to struggle, etc.
Yeah, that's like, there's like, once again, like a couple of things going on there that are really interesting. First off, you talked about, it's actually a psych term, hindsight bias, as you know, where like you like read an explanation and you're like, oh, I knew that, because you think that like what I know now, I knew back then, even though it was just like, a couple of seconds ago. And that's like a really common thing, especially when students are doing flashcards. They'll like look at the back of the flash and like, oh, I knew that. And then they'll put that in the pile of the stuff that they knew. It's actually a psych vocab thing that the MCAT will test you on, hindsight bias. But that happens a lot as students like look at explanations. I do also want to point out, when you're like reviewing, like if you like, maybe you did a calculation and it took a long time, make sure that you like go back and look and see, was there another way to solve this? Because very often there are multiple ways to kind of come at a question and figure things out and simplify. And I know that we're talking a lot about math here, and like the equations and the calculations, when really the equations and the calculations isn't the bulk of the questions in the psych section. Even though like 55% is chemistry and physics, a lot of those things are still pretty conceptual. But that is the thing that differentiates the chem-phys section from the other sections. So if I have a student that is like really struggling with the chem-phys, it might be like a math thing, where they're like going to like nitty gritty and trying to like solve things in a more complex way than they need to. And that might be why students are struggling in chem-phys. There's also a fair amount of data interpretation, though, pretty much on the same level as what's going on in the bio section. And so like if you find those two sections are both low, it might actually be more of a data interpretation thing. And it's not actually like a chemistry or a physics thing. Like it might actually just be like dealing with passages. And that's definitely a challenge that occurs in the chem-phys section as well, is learning to deal with all of the, like just the passages and understanding what they're talking about. But that also happens in especially the bio section. I actually think the bio section might have a little bit more difficult data interpretation than the chem-phys, but they're still pretty close. But we're kind of like trying to focus on like, if you're struggling in the chem-phys section specifically, how do you work on that? Another thing kind of in the realm of the math stuff is learning to round, because in undergrad, you are punished for rounding, right? Like if the answer is like 5.2 is like the pH of this thing, your chemistry professor, if they ask you what's the pH and you say, it's less than 6, more than 4, somewhere around in there, like that's not good enough for that professor. But on the MCAT, yeah, that's fine, right? Like that's completely okay. To have an answer that's like, it's somewhere around 100, when the answer is actually like 111. Like that's fine on the MCAT. And not only is it fine to round, but you kind of have to round. Like it's this weird thing where you're punished for rounding before, then you get to the MCAT, and now not only can you round, but you have to round. And so those things you were punished for before, you now are being forced to do. And a lot of students are not used to solving questions that way. Doing big ballpark, like they give you the density of seawater. I'm like, it's about the same as regular water. It's still a little bit more dense, but who cares? Or like gravity is 9.8. It's around 9. Like Faraday's constant, which is the charge for a mole of electrons. I think it's a little bit less than 100,000. It's like 96 or 98,000. I don't even know. I just say it's 100,000. And that's something that students get pretty uncomfortable with. And I think that's important to recognize. And there are some really interesting ways you can round to work a little bit faster. Like, for example, if your answer choices are like 1 times 10 to the negative ninth, 2 times 10 to the negative sixth, 3 times 10 to the eighth, and then 9 times 10 to the fourth, I don't even care about the exponents. I just care, is the number out front 1, 2, 3, or 9? And so when I'm doing my math, I'm going to completely ignore orders of magnitude, right? So if I have like 2 times 10 to the eighth times like 1.5 times 10 to the whatever, I'm just going to, no, it's 2 times 1.5. And I'm just going to pay attention to those numbers out front because that's all I need to solve in order to answer the question. And that will help me work a lot faster, and it'll help me like avoid errors, like because you like start to incorporate too many steps, and a lot of times students start to make some mistakes because they're trying to do too much at the same time. Where if I just ask you like, what's 2 times 1.5, everyone's like 3, and so the answer is 3. 3 is the answer to that question. The one that starts with 3. 3 times 10 to the whatever. I don't care what the whatever is because I just care about the number up front. And so once again, that's something that you are not allowed to do in undergrad. If your physics professor is like, what's the temperature of this? I'm like, it starts with a 5. It might be 5 million. It might be 50. It might be like, 5 Kelvin. But it's something with a 5. That's not good enough for that professor. But all of a sudden, that's something that you can do and should do on the actual exam. And so there's a lot of relearning like math skills, like learning how to round and when to round and how to take shortcuts on the math, because that's something that's totally fine on the MCAT and like required almost. And that's something that you like students try so hard not to do for like the previous 20 years of their life. And that's just like a hard habit to break for a lot of students.
I love that was what you decided to touch base on next, because that's actually exactly what I was thinking. And I also find it interesting. So this is the benefit of getting two co-hosts, right? So you actually focus on the number out front. I actually focus on the exponent, because for me, that's actually a lot easier to work through. And and this is just my personal preference, right? Everyone's going to have their own. But for me, I actually work better with just the exponents, but it's the same idea, right? Because in the example that you gave, those were quite a number of order of magnitudes different. And so if I see something and I know that it's 10 to the negative whatever, and all of a sudden, 2 of the 4 answer choices are a positive exponent, those are out. I'm not even going to consider those, right? So you can take, and we give these suggestions, right? You can still tweak them and make them your own as you're practicing. The idea is that you're trying to simplify your life. You have enough going on with the MCAT without having to add without having to add a whole lot of nitty gritty math in there. And so you want to make sure that you get comfortable with the basics, right? And then learn these, if math is something that you were struggling with, which like we talked about, it's not the bulk of the chem-phys section anyway. But if that's something that you notice that you're having difficulty with, make sure that you have the basics down and then try adding the tips and tricks. Because something else that I see is a lot of students will try and go for the shortcuts without knowing or truly understanding the underlying principles, and that's where they tend to get tripped up. It's the same thing with the concepts, right? So the concepts are the bulk of the chem-phys section. They, also underlie the data interpretation and also some figure interpretation, although that's a lot more biochem as well, like you mentioned. But if you don't have that basic foundation, all of those tips and tricks and shortcuts can get really messy really quickly. So the most important thing is to make sure that you have those concepts solid, down packed, and then you build everything else off of it.
Yeah, that's a really good point. Like, and I will do the same thing too. It kind of depends on what's different in the answer choices. If the coefficients out front are all different, then like I focus on that. If the exponents are all different, then I'll be like, is this somewhere around 1 million or somewhere around 100 or somewhere around 0.001? And like, you can just like pick your answer that matches just because it's the right order of magnitude or around the right area. But you're right that most of the time it is the conceptual side of things. Once again, I know I harp on this a lot, but that's because there's a lot of habits that need to be broken in students. And that's like what I feel like a good chunk of my time, what I do with students is like breaking some habits, that things that help them be successful before, but will hurt them now. I think a lot of students, because the math is the problem, will do just like flashcards of equations. And that that's not the worst thing in the world. But like you said, most of the problems on the MCAT, like the calculations and the non-calculation questions, are about understanding the relationships and like conceptually what's going on with this. Like as I get farther away from a wire, the magnetic field weakens. Like that's not something like an equation can tell you mathematically that, but you need to be able to look at something and just conceptually be like, oh, it's going to be weaker over there. And that's something that like just memorizing like orders of letters in an equation is not as good at as it is to actually do lots of practice questions, because then you start to understand when you can apply which equation and when you should apply which equation, and also just like a lot of covering the content overall as well. And so like reading, like listening to like videos, like watching like explanations of what's going on conceptually is, I think, really important. This, especially in the really complex like problems. So like in the scope of fluid dynamics, which in my mind is like probably the most difficult physics topic on the MCAT. Like fluid dynamics is like up there. If you're a fluid dynamicist, you're a smart guy in my book, or gal. The thing with fluid dynamics is there's really like three main equations you need to worry about. There's continuity, there's Poiseuille's, and then there's Bernoulli's. And I think a lot of times students will see questions, and like flow is in the continuity equation and Poiseuille's law. And so a lot of times students will get a question about continuity and they'll think it's a question about Poiseuille's law or vice versa, because they know flow has to do with each of these, but they're not sure what happens with each one. And that's why, like, when I lecture, like, the most important thing is to understand, like, what is this, like, continuity equation telling us? Basically telling us what flows into the pipe must flow out of the pipe. That's it, right? And, like, that idea is really important. And then if, like, the Poiseuille's law says how much will flow through a pipe under these scenarios. So, like, if you, like, narrow a pipe or widen a pipe or switch it from, like, water to maple syrup, or you like make the pipe longer, or like all sorts of things that can change this. Or you change the pressures on each side will change the flow rate. And so if I get a question, and this happens a lot, where a student gets a question of like, what happens to the flow as the pipe narrows? A lot of times students want to say, well, the flow is going to be the same. No, the flow is going to drop, but the flow in and the flow out are still going to be equal to each other. It's not like when you change the scenarios, the flows have to be equal. It's just whatever flows into the pipe has to flow out of the pipe. If you narrow it, you will still get less stuff flowing through the pipe, but what comes in and what comes out will be equal to each other. And that is a really like very conceptual thing of like understanding what's Poiseuille's for, what's continuity for. But like the vast majority of students are just memorizing the equations. And they're like, there's something here with like the flows in, like flow 1 is equal to flow 2. And they're like, oh, like the flow original and then the flow final after you change the pipe, those have to be equal. Like, nah, that's not what it's saying. Just the flow in and the flow out are the same. And so like that's a really like nitpicked example that I see students miss those questions all the time, because they know the equations, but they don't know when and how to use them. And so like flashcarding equations will not help you with that. What will help you with that is doing practice questions, or like reading in a book, or like watching a lecture. That will help you understand those conceptual applications. And I know we already mentioned this, but like this stuff is really important. Fluid dynamics is really important for cardiologists. So that's the other thing I hear all the time is like, why do I need to know fluid dynamics? Why do I need to know nuclear physics? I'm like, well, if you're a radiologist, you have to know nuclear physics. If you're a cardiologist, you have to understand fluid dynamics. And so this stuff maybe won't be useful for every single doctor, but all of this stuff is useful for some kind of doctor. And you don't like even if you think you know what kind of specialty you want to go into, there's a good chance that's going to change at some point in your medical career. And so like to say like I won't ever need to know fluid dynamics, maybe you're like, hold off, maybe you will. Yeah.
And just to kind of add on that, because I think I was definitely one of those students who, had you a couple years back, if you would have asked me, okay, how much do you actually care about what you're learning about on the MCAT? I would have said, it is just a stepping stone. I just need to get to medical school. That is it. But here's the thing. It's not just that you'll need it when when you enter that specialty, it's something that you need the entire time, right? So when we first started our foundations course, which was our very first, integrated course, lots of different aspects. I remember we did, this was quite some time ago. But we did a lot of different topics, and we started doing some biochem in there. We started seeing some chemistry. We started seeing some physics. And that was the very first course that we did in medical school. And as of a few weeks ago, still trying to figure that out, we did cardiovascular system starting in February for a few months. There was plenty, and respiratory system as well. Plenty of fluid dynamics there, right? When we did the renal system, right? The kidneys, there was a lot of understanding the principles of electrochemistry, right? We're not doing the nitty gritty, okay, what is the electric force that's repelling, this charged ion and preventing it from being, excreted or something like that. But it was as the sodium moves, right, what's happening to the relative electronegativity or electronegative lumen, right, inside the nephron, that's going to drive the movement of sodium, potassium, etc. And so you may not need these specific topics in depth, right? You may need a general understanding of them when you get to medical school and onward, but having that really strong understanding now will make you more likely to remember those basics when you get to medical school, when you're practicing, right? And this is something that, when you're taught in medical school, you're also taught by physicians from many different specialties. And so they're going to have their particular area of focus. And so they're going to have forgotten a lot of the more complex topics, right? But they'll still also remember the basics. And that's what they're going to be using to explain to you these ideas, in addition to whatever's relevant to their particular field. So it's really easy to brush it off and say, okay, well, I'm not going to be a cardiologist. And I know I'm not going to change my mind because I really don't like hearts, right? Whatever. But these topics, these basic ideas will follow you for many years. And so getting comfortable with them now just saves you a lot of trouble and headache later on. So that's that kind of idea that I really wanted to put out there, because as a pre-med, I know what I would have been thinking and saying and laughing off in my head right now, listening to our podcast. So I just wanted to put that out there. The second thing is, we've harped a lot on the math, right? We've harped a lot on equations, et cetera. It started touching base on concepts. I think something else that, in a sense, deserves its own podcast is a little bit of data interpretation, and kind of understanding the chem-phys section has so many different types of figures that you might see, right? It's not just tables, it's not just graphs. You're also going to be seeing molecules, something that a lot of students freak out about in the chem-phys section in particular, and then to some extent the biochem section as well, structures. And they'll say, well, I didn't know what, whatever structure looked like, or I saw this structure on the passage or in the passage and I freaked out. I didn't know what I was looking at. And coming back to the basics, okay, follow the electrons, right? The difference between an electrophile and a nucleophile, and the general preference for each of these in terms of how the electrons are going to move, right? And then basic structures. If they ask you something about, right, what, like a steroid, right? You're looking for 4 fused rings reminiscent of cholesterol. So you can still use a lot of that basic level knowledge that you have for orgo, for chemistry, for biochem, and then layer it on in the chem-phys section without having to sit down and memorize 60 different structures, because that's not a good use of your time, because that time that you are sitting down memorizing structures you're unlikely to see on test day takes away from the time that you could be spending reviewing the concepts, making sure that you have a good understanding of, so you like fluids, I like optics, like lenses. So something that I'll often see students do is I don't even know if this is a word. If you know if this is a word, feel free to correct me.
Make one up.
Over-mathematize. I don't even know.
I love that.
But with certain topics. And so, the same way that students will try and sit down and memorize things they don't need to sit down and memorize, they'll often try and apply a lot of math that they don't need to apply. So, for example, students will try and sit down and memorize a list of what happens when they move an object with respect to a converging or diverging lens. Usually converging is a little bit trickier for students. And so what I'll often do is I'll say, put your hand up. You have a camera in front of you. What happens when you get closer to the camera, right? What happens when you move your hand farther to the camera, from the camera? What happens to the size of your hand? You know these things, right? When you're sitting at a movie theater, they're projecting that image through a lens, right? So what happens? Do they have that image super close to the lens that they're using to project it, or do they have it super far in a different room, right? You know it's not in a different room. So it's closer and it's projecting a larger image. You know these things, right? You live in a world that is dominated and governed by the laws of physics. So just sometimes stepping away from the nitty, and I'm saying nitty gritty a lot today,
Yeah.
but stepping away from that and just saying, okay, how does this actually work? Like, without trying to get super scientific about it, just I live this every day. How does it work? But that's kind of, yeah.
I love that over-mathematizing, just the idea of like hand close to the camera, like, oh, it turns out it's bigger. Nobody's surprised by that, right? Like what's going on with that is super interesting. There are like lots of other examples of this, but I think maybe like one of the biggest things here is understanding like the fundamentals and how they're related. I think that's something, first off, that just happens no matter like what your field is. The further you go in your education, the more the lines get blurry. And I feel like the MCAT is very often like one of the big first steps of realizing like, this is kind of biochemistry and physics, like all together at the same time. Like what's happening with your eye as you like move objects and like that sort of thing. All of that makes sense. Another like concept that a lot of people don't think is physics or chemistry is like sun can cause skin cancer, right? Like sunlight can. Like that's a lot of people, that's a biology topic. But then you stop and you realize like, wait a minute. So like the light from the sun, the photon, is knocking an electron off of my DNA molecule. That's the photoelectric effect. This is like a chemistry physics thing. Like the photon has to have enough energy. So it's got to be above the visible spectrum, like an ultraviolet ray. And like that's like if a photon's got enough energy, it'll knock that off. Note that it's actually it's a lot easier to knock electrons off of aromatic things because they have like resonance stabilization, and your DNA is like the bases are aromatic, like the A's, T's, C's, and G's. And so that's why like the sunlight ultraviolet rays will damage your skin. That's orgo. But then like looking at the actual like pulling off the electron, what you're doing here is you're pulling this negatively charged electron from the nucleus of an atom. That's electrostatics. You're just like separating like positive and negative charges. And you can actually calculate a lot of that stuff using just like your electrostatics equations. And so like something as much as like, you know, like sunlight makes your DNA mutate. That's physics and orgo and chemistry and biology. And it's like all of these things that's all kind of together. And I think that that's how you should be thinking about these things, is like, how do these things relate? And like you talk about like trying to memorize all these things. That's something that happens like as you go along. And a lot of people think med school is going to be just memorize like all the drugs from beginning to end. Like that is not a good strategy. What you need to do is understand some like fundamentals, like to like step back and make a really obvious, exaggerated example. If I drop like a Gatorade bottle, it falls down. If I drop like a bowling ball, it falls down. If I drop like an apple, it falls down. I could sit down and try to memorize like a list of all the things that fall when you drop them. Or I could understand the idea behind that is like things fall when you drop them. And like that one thing I can now apply to everything. So if I'm on a test and somebody says like, what happens when you let go of an aardvark? It falls, right? Like I didn't memorize that, but I understand the idea behind it. And that's how you need to like tackle a lot of this stuff on the MCAT, but especially the chemistry and physics, because students compartmentalize those so much and they don't think like, oh, this is physics, this is chemistry. They think stuff is just biology, but obviously these things are really related. And like the fundamentals of pretty much every biological interaction is chemistry or physics at some level. Like why do hydrophobic things interact? Like why does ibuprofen need albumin to carry it around in the blood? Well, that has to do with like polar and non-polar interactions, and like albumin can carry this non-polar thing, and warfarin and like ciprofloxacin, and like all those drugs are kind of like hydrophobic, and so they all kind of need like a carrier because they don't dissolve well in blood, because blood is mostly water. It turns out like hydrophobic stuff and hydrophilic stuff don't mix, right? And like that's like a really fundamental idea. But once you understand that, you can now like apply that to all these things. And I could give you the structure of a drug and you could tell me like, that like if somebody's low on albumin, which is a protein that carries hydrophobic molecules, we might have a hard time delivering this drug inside the person's body. And like that's not something I'm going to memorize, but that's something if I understand the fundamentals of how these things work, all of a sudden you can make these connections. And that's what the MCAT's about, because all the passages are like mixtures of all these different things. And you have to like read between the lines and make those connections. And that's not how students are used to learning. And so I think that is probably the biggest challenge with the chem-phys section, is just starting to understand the fundamental ideas and being able to relate them.
Yeah, you've heard us say this, right, from the moment that we started this particular podcast up until now as we wrap up, right? This section is not a section to approach in isolation. This is a section that incorporates, like Phil has mentioned, right, essentially all of the sciences. And actually, you'll even see some of the, the components of the eye, and thinking about how you actually might even see a question about like vision, right, on the psych-social section as well. We know that. So all of these topics, you want to consider them in the context of the rest of your learning for the MCAT, right? As you're studying the concepts, make sure that you have those underlying concepts really solid, have that good foundation, right? You're going to see questions that incorporate some math, some equations. Like Phil mentioned, right? There are a few questions that are going to be really, really difficult math, plug and chug. You're not going to see 3-4 minutes of calculations worth of questions on the chem-phys section. If you see that, pause, something went wrong, right? You might want to rethink how you went about that question. So we're sending you off into the world, into the MCAT prep world, just reminding you this is a section that you're going to progress in, right? Little by little, but that progress is cumulative. And so one day you might sit down, you might say, hey, this makes sense. I know where this is coming from. I can see how it relates to this other topic. I'm moving in the right direction. And that's what we want for you, so that as you go through, you can feel like you're progressing without freaking out that this is going to be just like undergrad, because it's not, thankfully. Anything else that you want to add, Phil, before we wrap up?
No, I mean, like I think that like everything that we've talked about is clear. That like cumulative stuff is really important. And so a lot of times a question will require you to know multiple things. And so a lot of times students will miss a question and they will feel like they haven't learned anything. But like maybe you picked up like 2 of the 3 foundational ideas that you needed to solve this, but you're still missing 1, which means you have progressed. And so be careful with that. Kind of like judging like purely off of scores, like trying to judge your progress off of that, because a lot of this stuff is more about how you think about it and how you can connect things. And it's not really about how much you have memorized. And that is, once again, different from undergrad. And so you have to like think about this, like how stuff is being tested and how you need to approach the topic overall.
For sure. Thank you guys for listening. Join us in next time. Remember, subscribe so you can get notifications when our next podcast is out. And we'll be here next week with you.